Hello, everybody. How are you? Good evening or good afternoon, wherever you are. I'm in Pittsburgh, Pennsylvania, and the sun is still setting. But that's okay, because it's time to do some math problems. Actually, the sun's not setting at all. I don't know why I said that. But I feel like the sun should be setting because I'm going to be doing a bunch of live streams tonight. But this is the one that I'm very excited about kicking off, because we're going to be working on some problems that MathCounts created. I always want to mention this at the beginning. This is an official collaboration with MathCounts, and so we'll be using the actual MathCounts problems from this year. Now, I'm emphasizing that because MathCounts problems are copyrighted, and so it's important that one doesn't just go and copy these all around. However, this is officially working with MathCounts, and that's a real pleasure because MathCounts is actually how I got really interested in math when I was in middle school. Alright, now the way that this works is that we will be looking at me attempting to solve problems. These are actual problems from this year's competition that I haven't looked at before. And I do that on purpose because I want to show people how you might try to think about solving a problem if you haven't seen it before. And the best way to learn how to do that is to watch somebody struggle live on YouTube. And of course, there's all these really wonderful people who are in the comments. And you guys are welcome to chat amongst yourselves, spot my mistakes, and maybe even solve the problems as you go. Is everyone ready? Let's get ready to go. So let's switch over to the problems. Here we go. The first question for today comes from the sprint round. And the sprint round is a competition, it's a round of the competition where you have 40 minutes to do 30 questions. We're already at the chapter invitational level, and that means that the problems are getting harder and harder. We'll see how easy it is to get through these. We're reserving 3 hours to think about these, an hour today, an hour tomorrow, and an hour on Monday. And the first question is, what is the arithmetic mean of the terms in the arithmetic sequence 12, 18, 24, 30, 36. Oh, okay. Well, thank you very much for telling me that it's an arithmetic sequence. And I'm looking for an arithmetic mean. So they're already in order. They're already from like smallest to largest. And so therefore the answer should probably be the number that's right smack in the middle, 24. That's what happens. The arithmetic mean is the average. And if you're going from small to big and there's an odd number of numbers, the arithmetic mean is going to be in the middle. The arithmetic sequence very conveniently adds the same thing every time. So my answer, I think, is 24. Let's find out if that's right. It is. Okay, we got 1 point. Let's keep going. The second question says, if Skylar colors 1/2 of 2/3 of the squares in this figure, how many squares did he color? Okay, well, I see 1/2 of 2/3, and 1/2 of 2/3 means that I want to take a half of is times 2/3 of the total. That's what I want. But when I see that there's a half and a 2/3, and there's both of these 2's, those cancel. So I just want 1/3 of the total. Now it becomes a counting game. How do you do this? Well, you just start counting. 1, 2, 3. That was supposed to be a 3. 3, 4, 5, 6, 7, 8, 9. Hooray! It's a multiple of 3 because it's 9 times 2 is here. So I want 1/3 of 9 times 2. That cancels nicely. Always divide first instead of multiplying. That's a nice trick to have smaller numbers to deal with. So that cancels a 3. And so 3 times 2 is 6. Reading the question again just to make sure we didn't make a mistake. Yes, coloring that much, coloring. Yeah, 6 squares. Let's try. Is it 6? It is 6 squares. Next question. What is the median of the first 7 prime numbers? Ooh, okay. So when I'm talking about the median of 7 numbers, I don't need to write all 7 numbers, right? Actually, if you want to learn a college class on math, I'm live streaming my whole Carnegie Mellon class right now on combinatorics, and I was teaching them blob math. Blob math means you start by being way too lazy to actually write down the numbers. This is actually what we learn in college. So I got 7 numbers. See, they're the blobs. These are the first 7 numbers. You just can't read them because they're too small. No, they're not too small. I just wrote way too messy. See this? Those are the 7 numbers. So now, if these are the first 7 prime numbers, the median is the middle blob. So it's the 4th one, all right? So once I saw all these blobs, now I just go and say, I just need to know what's the 4th prime number. I actually remember that there are 4 single-digit prime numbers between 0, 0 is not prime, 1's not prime, but it starts from 2 and it goes up to 7. So I actually know the answer is going to be 7, but that's because I know that the primes are 2, 3, 5, 7. Somehow, whenever I did enough of these math competitions, I just got used to the idea that there's this nice diagram we can draw of primes. By the way, I'm already going to propose my answer to be 7. But while I have 2, 3, 5, 7 here, I want to just say, in my head, the picture of the primes looks like this. 13, 11, 13, 17, 19. And then it goes 23, 29, 31, 37, 41, 43, 47. Somehow the primes up to 50 were always important for me. And I just remembered that it was like 4, 4, 2, 2, 3, something like that. If you write this down enough, you get it. Okay. By the way, I see that somebody complained that there's a buzzing sound. Sometimes that has to do with my microphone. But if you do all hear like some buzzing sound, let me know. I'll try to figure this out. In the meantime, I was just like, okay, first 7 prime numbers, the median is the 4th number, so I actually just need the 4th prime. Something in my head told me, oh yeah, there's 4 primes in the first row of the prime number table, so you go get 7. No buzzing, air conditioning. Yeah, there's some kind of an air handler here, that is true. Although actually the sound, because I'm actually in an office which is above, it's above some kind of a convenience store, and they have a lot of refrigerators down there. So what you're hearing is the refrigerating unit downstairs. It's not warm enough for air conditioning yet here. All right, 7. It is. Next question. What is the absolute difference between 5 less than the number n and 7 more than n? Okay, it's like translating the wording, right? 5 less than the number n, that's n minus 5. Oh, you know what? Oftentimes I think of these even like on a number line. That's a number line. Here is n. And I want to know the difference between 5 less than the number. So, okay, this is n minus 5. And 7 more than the number. That's over here. N plus 7. Actually, once you see it on this number line, you can see what you're going to do is you're going to take 5 plus 7. That's all that's going on. This is a gap of 5. And this is a gap of 7. So that means that the absolute difference between these two numbers is 5 plus 7, which is 12. So I think the answer to this is 5 plus 7, which is 12. And if you can see, I'm going kind of fast through these first ones, because I'm actually kind of scared. If I was really doing this contest, I would say, it's chapter invitational, so the problems are going to get hard soon. So even though these look like I can do them, I might need to save my time for later. Let's see. It's 12. So far, so good. Question 5. What is the distance between points A and B on the coordinate grid shown? Oh, okay. By the way, the question doesn't say express your answer in simplest radical form. It doesn't say express your answer rounded to the nearest tenth. It just says the distance. That means it's usually a whole number. And in fact, this is one of these famous triangles, right? It's 4 across this way. Where's the A? A is 3 up. So what I've gotten here is I've gotten, oh, you know what? Let's use the big highlighter. I've gotten this. It's a triangle, and the lengths are 3 here, 4 here, and this is famous. It's a 3, 4, 5 right triangle. This is the square root of 3 squared plus 4 squared. That's the Pythagorean theorem. The square root of 9 plus 16. The square root of 25. That's 5. And this is a famous Pythagorean triple. Okay, let's see. Is it? Oh, look at that. It's 5 and it's question number 5. Usually this is intentional. 5. Next question. Regular hexagon A, B, C, D, E, F, shown here, has area of 5 square units. What is the area of the trapezoid B, C, D, E? Oh, okay. That's cute. So I need to know the area of this trapezoid. Wow, this sounds like it's going to be so hard because, you know, like 5 square units, where are all the square root 3's? Well, what if we try not to think about using formulas and instead think about reasoning? I guess there's like 5 square units all around. I mean, the whole thing. And what's this guy? It looks like half of that, right? So half of 5. That means it's 2.5. And it says nearest tenth. How convenient. That is the nearest tenth, 2.5. Let's keep going. What's next? Oh my gosh, black pen, red pen is here. Hello, black pen, red pen. Nice talking to you earlier this week. Let's keep going. 2.5, 2.5. Yes, it's 2.5. Let's keep going. Next question. Number 7. What is the value of the expression? Okay, so on this particular one, it's hard for us to make slides. When MathCounts makes problems, they make the problems printed much nicer. But for us, sometimes it's a bit hard to draw. So we want the square root of this whole nonsense. Oh my gosh, what's this? I guess I have to do some arithmetic, okay? Let's see. Do I see any kind of a... I don't see any kind of a shortcut right now. So let's just do it. So 9 squared gives me 81. 81, I have to subtract 5 times 4. And then plus a 12 divided by 4, that's 3, okay? And I like to, I guess, get my numbers smaller if I can. So I get 61 plus 3 is 64. That makes me happy because that's the square root of 64, which is a perfect square, and that's 8. And again, with math counts, they didn't say express the answer to the nearest tenth. They didn't say like simplest radical form. So we just go straight to a whole number, and that makes us happy. Let's try 8. Oh, I saw somebody in the chat says plus or minus 8. So actually, let me talk about the difference. If somebody told you, okay, let's think of something else. If somebody told you, solve x squared equals 64, well, that has two solutions, okay? That has two solutions. X is equal to plus or minus 8 because both plus 8 and minus 8 work as the solutions. But if somebody writes the square root sign of 64, that actually always means the positive square root. So this is something we've decided, I guess, as a society. Whenever you write the square root sign, you are referring to only the positive square root. There's a reason for this. It's because it's nice to be able to say, I want this symbol to represent exactly one number. If you wanted to express both square roots, you'd have written a plus or minus in front of this symbol. So that's the difference between solving an equation and evaluating an exact symbol, right? And so this is an exactly written symbol. That means it's the positive square root. A little bit of me wants to be kind of silly here and say, you see, the reason why it's so important to have a convention is because there are some numbers for which it's not completely clear what should you write as the, like, is it positive or negative? And that's like, if you had like a I, if you had an imaginary number, it's like, is I positive or negative? That's actually a deep question. So I won't go deeper into there. That's actually something that you learn in high school. But let's go on and go with the 8. Yes, and the answer to question number 7 was 8. Next question. Question 8. Given that 3a plus 5 equals 7b minus 11 and a equals b, what is the value of a? Oh, a equals b? Then why is there a b? Get rid of it, get rid of it, get rid of it. Okay, so 3a plus 5 is equal to 7a minus 11, okay? I've just incorporated information. Although part of me always wonders, should I replace the b with the a or replace the a with the b? And I'll tell you why I chose to replace the a. It's because I don't like the letter b. No offense if you have a name that starts with B. I don't mean I don't like you. What I mean is that writing the letter B in my scratch work is horrible. Do you know what happens when you write little lowercase b? What might happen? B is a very dangerous number. It looks a lot like 6. So I'm very scared of writing the letter B. All right, so I read A. A is, what kind of number is this? A 9? Oh, no, this is too short for the 9. Anyway, let's solve it. So 3a plus 5, okay, so I've got 4 a's over here is equal to, add 11 to both sides, I get 16. Okay, a equals 4. Hooray! I think that's the answer, 4. Let's see what the next one is. It is 4. And question number 9. An album with 12 songs costs $9.99. If Andy buys each song individually, he pays 99 cents per song. How much money can Andy save by buying the album instead of each individual song? I am too lazy to deal with all these 9s. We're going to round things to 10s and 1s soon. But first, let's go and find out what I need to calculate. I need to know how much you save by buying the album instead of each individual song. And there are 12 songs, okay? So if I went individually, what happens when you buy individually is you'd be getting 12 times 0.99, okay? And if instead what you did is you went with the whole album, it's $9.99. Now, I want to know the difference between these two. And I'm like, those are a lot like full dollars, okay? So the way I think of this one is this is $12 minus 12 cents. right? Because it's like 1 cent less from $1 12 times. And this thing here is $10 minus 1 cent. Okay, I want to know the difference between these, so I want to subtract. And so let's do a big subtraction. Minus. Okay, let's pretend I was doing a big subtraction. Then what do I get over here? When you subtract, you can actually subtract column by column also. And 12 minus 10, that's 2. Okay, and now I need to know what happens when I have minus 0.12 minus 0.01. Double negative makes a positive. And so that's going to give me minus 0.11. Right? There's multiple ways to look at this. One is to just say, hey, look, let's carry the minus sign down and take 0.12 minus 0.12. What is that? No, 0.12 minus 0.01. And then you get 0.11. Another one is to think, well, I've got negative 0.12, and then plus 0.01, that's negative 0.11. Okay? But no matter what, however you do it, we get this. And then we go and simplify this. This is equal to 1.89. And that would be the answer that I suggest here. And of course, you read the question again because these kinds of things have lots of stuff going on. Does it make sense? I'm like, well, look, it was $10 instead of $12-ish. And that's about right. That's about $2-ish for the difference. So that I'll go with 1.89. Okay, I see some people are commenting about how this is not true in real life. I guess I actually don't even know how people buy music nowadays. It is true that you used to buy music on these like CDs, but I get the sense that we don't use CDs anymore. I'm going to stop sounding like I'm too old for this. Let's keep going. All right, emoji time. That's much more modern. What's the integer value of, what the heck is that? Oh, it's a fox. Oh, no. Is that a Doge? Anyway, I don't know. It's like some like animal thing plus the ice cream sundae plus the ladybug, given these three equations. All right. So, what do we do with? Oh, it's a corgi. Oh, it's a corgi. Okay. It's not a Doge. The Doge looks different. Okay. At least I won't pronounce it a doggy. Let's keep going. I need to know the sum of these three things. Okay, let's start solving the equations. Okay, so corgi. Somebody tells me that, or is it pronounced corgi or corgi? Is it a corgi? Corgi? Let's call it corgi now. Right. So let's say this. I've got three corgis. That's 90. So that tells me that how am I gonna draw this thing? I guess they have ears. Okay, so that's what I'm gonna do. That thing is equal to 30. Okay. Once I got that thing is 30. Ice cream I know how to do. The ice cream is, I use this guy, right? So I know that that's 30. So therefore there's 2 ice creams. That's 30. And so that means that each ice cream is how do you draw an ice cream? This thing. That's equal to 15. Okay, and then we got ladybug here, and I've got like 2 of these guys. That's 60. 60 minus 20. Okay, so the bug. That was 60, so the bug is 20. Bug. Okay, so I've got each of these 3 things. Add up the emojis, and I get, oh, that's cute. 3 plus 2 plus 1 is 6. That's something I've seen a lot. So somehow if I add up all of these things together, which was the question, it would be 65. So I'm going to go with 65. Let's see. It's a Sunday. That's what this was. Okay. I think the answer is 65. Let's find out. It is 65. Let's go to... Oh, that was a strawberry? Oh, no. Do I not know my emojis? That is not a strawberry. That's a ladybug. I think it's just that maybe my... Yeah. I think maybe my font wasn't quite showing up. But the thing that was here is actually a ladybug. Okay, let's keep going. Very good drawings. Well, that's the best I can do. All I can draw is lines and circles, actually. Any of this other fancy stuff is too hard. All right. Number 11. At Alicia's new job, she works 3 days a week for a total of 45 hours per week. At her old job, she worked 4 days a week for a total of 40 hours per week. Wow, these are long days. Anyway, I'm just looking at this. I'm like, 3 days a week for a total of 45 hours per week. Wow, that's a long job. I have a lot of respect for Alicia. What is the absolute difference between... Yeah, that's what this is about. What's the absolute difference in the average number of hours Alicia worked per workday at her old and new jobs? This is crazy. Okay, so the old one, right? So the old one was 3 days a week for a total of 45 hours per week. So 45 divided by 3, that's 15. 15 hours per day. This is insane. And the reason is because, you know, like, does anyone know how healthy like sleep is? Oh, that was a dumb question. How many hours are you supposed to sleep a night? A lot, right? Like 8. So this is pretty tough. There's not much time to eat or like take a shower or anything. Anyway, so the other one is 4 days a week for a total of 40 hours per week. I see that people are saying sleep more than 9. That'll actually help you recharge better. Good idea too. Somebody says sleep at least 3 hours. I sure hope so. Okay, next one is 4 days a week for a total of 40 hours per week. So that's 40 divided by 4, 10 hours per day. By the way, this is still pretty hardworking. Lot of respect for Alicia here. And the absolute difference is 15 minus 10. That's just 5. See, we're working much less than this. We just subtract 15 minus 10 and then we call it 5. And we say we've done our work for this problem. But anyway, so the answer is 5, I think. Let's see. 5. And I should also say, there are some people in the world who do work that hard. And so that's what I mean. Mad respect for Alicia. Okay, next question. Exponents. Question 12. What is the value of x to the x if x to the x? No, what is the value of x if x to the x is 256? Well, something that's good is that if you take stuff to stuff, it gets huge really fast. Like, you know, 10 to the 10, it's got like 1 with 10 zeros. So it's not as big as 10. 1 to the 1, well, that's just 1. So we don't have to try that many things, okay? And oh, by the way, it's even. So don't even try to do something like 3 to the 3. It's even, right? So the first choice is, how about 2 to the 2? Well, that's kind of boring. That's just 4. What's the next choice? 4 to the 4. What's this? So 4 to the 4, that's like squaring it and squaring it again. It's like 4 squared and then squared. That's one way to look at it. And actually, that's good because that's a power of 2 over there. And this is also a power of 2, right? So if I'm thinking of this, you know what? Why did I do that? I did that because that's one way I can solve this. It's like 16 squared. And I actually have seen that 16 squared is in the 256 range. There's another way you can think about this. This is supposed to be an equal sign, okay? The other way is that 4 is 2 squared. That's another way to write 4. And then raised to the 4th power. And if you're going to take 2 squared, that's 2 2's. So 2 and 2. And then you like take the 2 and 2 and multiply them together 4 times, you're going to get 8 2's multiplied together. That's 2 to the power 8. And actually both of these, that's 2 to the power 8. And actually both of these are 256. 256 is a very important number, precisely because it's this power of 2. And you can get it in these multiple ways. So the answer is 4, because I would just take 4 to the power 4. Okay, let's see. Is this right? And if somebody said 8 to the 8, that's actually quite big. Because, you know, 8 cubed is already 512. So these things to the power, they grow really, really fast. Let's see. It is 4. We're on a roll. I'm kind of going through these relatively fast because I'm just not sure if there will be some really, really crazy questions coming soon. Next. Question 13. What is the least positive integer that has 5 distinct prime factors? Okay. Well, if I want to have distinct prime factors, I have to have different prime factors involved. And if I want the least one, I just want like the smallest 5 primes, I think. I'm going to have to read the question again to make sure I didn't do some mistake. So I'm going to first, before doing the computation, I'm going to write down what I would like to do. I would like to multiply the first 5 prime numbers together. And then I want to read this again because I'm wondering, is it like it needs to have 5 distinct factors? But no, it's a prime. So in order to even have 5 distinct prime factors, I better have 5 different primes involved, or else I wouldn't have a chance. And so these are the first 5 primes. So I got to do at least this. Let's try it. I guess it becomes a multiplication problem. Ooh, fun tricks. First of all, 2 and 5. Save those for the end because I love multiplying by 10. It's very relaxing. Next, I see an 11. There's a trick for multiplying by 11. So I'll save that too. That was a TOO. I'll save that as well. There's no 2 in here. TWO. Okay. Then I do 3 times 7 first. That's 21. Do you know how you multiply by 11? 21 times 11 is equal to, you write the 2, you write the 1, and sandwich in the middle, you write 2 plus 1. You add the 2 together, 3. Okay? And actually the reason why it's true, since we have a few moments, why is it true? Look what happens. Here's how you multiply 21 by 11. Look, there's a 21, and there's a 21, and what did you just do? You just put the 2 and the 1, and in the middle, you put the sum of them. So that's why this trick actually works. 2 plus 1 is 3. Okay? So I have 2, 3, 1, and that was all this stuff. And don't forget that there's this 10 over here. That was the 2 and the 5. So I get that the answer is 2, 3, is 2, 3, 1, 0. Actually, that's really cute. 2, 3, 1, 0. I like this problem. I didn't even know that would happen. Did anyone else know that if you multiply 2 times 3 times 5 times 7 times 11, you just get like different numbers? I think that's actually really cool. Actually, first let's check if it's true. Yay, we got it. Okay, I'm a little bit worried because I never know if the question will be too hard or too easy. But somehow like 2, 3, 1, 0, that's very satisfying. Actually, I can tell you, I'm one of these guys who looks at like patterns in numbers. And so if you actually get like this thing where it's all of the smallest digits all mashed together, that's just cool. Okay, this deserves to be put on more math contests, all right? Like this sheer fact that 2 times 3 times 5 times 7 times 11 is 2, 3, 1, 0, that's cool. Wow, very satisfying. Speaking of satisfying, I'll tell you, actually, this is no longer useful. It's not confidential private information anymore because it's from an expired passport. But I actually, on my previous passport, I used to travel around and give talks. But my previous passport number, I can remember because it was 456312700. And when that came in the mail, I was like, oh my gosh, what is the chance of that being your passport number? And at some point I had to go and, renew the passport. And I was just so disappointed that the new one wasn't like nice anymore. In fact, I don't even remember the new number. But like, that's just like, these are just super cool coincidences. Sorry, I'm just like a math numbers nerd. But when I see that, okay, this thing here is stupid. But that thing up there is actually really neat because that's just the multiplication of the smallest prime numbers. And don't worry, I didn't reveal any personal information. This is an expired passport. All right, let's keep going. Next one, question 14. Jasmine. Jasmine estimates her maximum heart rate in beats per minute by subtracting her age from 220. Oh, I didn't know that. I've just learned something new. Oh, okay. I get it. Yes, as you get older, it's probably not as healthy to have a very high heart rate. I get that. Okay, Jasmine's heart rate during exercise should be between 50% and 85% of her maximum heart rate. Oh yeah, that's the whole point. Actually, if you've noticed, this is how I read a problem. I'm like, does it make sense? I get it. Okay, good. Let's keep going. And now Jasmine is 20 years old. What is the highest heart rate in beats per minute that she should have during exercise? Nearest whole number. Oh boy. Okay, let's go and highlight the important information. So I'm going to have to do something with the age from 220, and here's the age. 20 years old. Oh, that's nice. That's 200. I like subtracting those numbers, all right? So I know that already. And there's also this thing about like the highest heart rate. Well, let's just go use blue for this. That's 85%, right? So I need to know what is 85% of the highest heart rate. Okay. So I need to know what is 85% of the maximum heart rate, which is 200, because you subtract her age from 220. I can do that because 85% of 100 is 85. So 85% of 200 is just double of 85. Oh, let me say, there's a student who was actually, he was a MathCounts student of mine a long time ago. Now he's a student at Carnegie Mellon, and in normal circumstances, he helps me coach a local MathCounts team. And he loves this trick. There's a neat trick here where, by the way, if you have 85% of 200, that's the same as 200% of 85. And that's because the percent sign, all it does is divide by 100, okay? And you can either divide by 100 first or second. But look, what's 200%? Times 2. That's really nice. So it's just double of 85. Very convenient. And I actually really like that trick that he enjoys too. So whenever I see something like this, I'm like, who likes 85%? What kind of a crazy number is that? But 200%, I like that. That's just 2. 85 times 2, that's like 80 times 2, which is 160. Plus a 5 times 2, that gives you an extra 10. So I get 170. When I see this, a little alarm bell goes off in my head saying, hang on a second, nearest whole number, but I didn't have to do any rounding. Did I screw up? Quick check, because sometimes it means you screwed up. So it's like, okay, what happens? What happens? So subtract the age, that's 20. Okay, so 200, all right. And that's like the maximum heart rate is 200. 85% of 200, that's what I want to do. Okay, maybe that's actually right. Let's see. 170. Good. I'm thinking to myself, does that actually happen? I could imagine that actually. Because if you know, like when you're really like playing a sport or something, your heart rate does go up. And if you think about how many times it's beating per second, that's how I was comparing it. Like that's like 3 per second. Could be. Next question. Question 15. The arithmetic mean of 3 distinct integers is 11, and the range of the 3 integers is 2. What is the smallest of these integers? Well, what I'm seeing right now, some interesting things are there are 3 distinct integers, and this deal about the range being 2. See, the range is the difference between the biggest and the smallest. But if there's 3 distinct ones, how can you do it? They've got to be all smacked together. And by the way, when I see a question like this, I say there's not much information. And if there's not much information, I should be able to do this without having any equations or anything. It somehow seems too little information. So I got these 3 numbers, blob math. So I've got these 3 numbers. Whoa, that was bigger of a blob than I wanted. Here we go. So I've got like 1 number, a second number, and a third number. And guess what? They're just consecutive on the number line. Always draw the number line first. Do as I say, not as I do. But so you have this thing, and the gap has to be 2. And so I know that the mean, that's the middle one, that's 11. And so that means that the smallest of the integers must be 10. Let us see if that is correct. It is 10. All right. Question number 16. Okay. So we now have let A ampersand B be equal to AB plus B plus A minus 1. If A ampersand 7 is 70, what is A ampersand 3? Ooh, okay. The first thing I look at is I wonder, is there a way I can simplify this algebraically? It looks awfully tempting. It looks sort of like a factor by grouping, but it's not because there's a minus sign. If there was a plus sign, it would be a nice expression. Okay. Although, actually, I want to do that anyway. It's easier for me, okay? So let's go and mess around with this with a way that might not exactly be how the problem had intended for, but it's good for lazy people like me. See, this is why B is so scary. Every time I write a lowercase b, I really try to make sure it's got a big vertical thing so it doesn't look like a 6. You see, this is a nice expression. AB plus B plus A. Oh, come on. Minus 1? No, plus 1. Uh-oh. That's cheating. You can't do that. Better put a minus 2 to fix it, right? Because it's supposed to be minus 1. Aha, why did I write this? I wrote this. Oh, what does the ampersand mean? Ethan asked. What the ampersand means is that people decided to invent a new symbol called ampersand. Or that thing, okay? And it's just a new symbol. And this is a common type of question that you'll see on math competitions, which is if somebody just invented a new symbol, you know, like they weren't satisfied with addition, multiplication, subtraction, division. They were like, and you also want to add this guy. And they just defined it. They defined it to say, if you see it, just do that. But you see, I don't like this expression. It's too complicated. I like this one better. And the reason is because this factors. This is a wonderful factorization. If I have AB plus B, that is A plus 1 times B plus A plus 1 times what? Times 1, okay? Minus 2. Aha. Now, actually, that factors again. This is called factoring by grouping. I can go and pull out A plus 1 times B plus 1. That's what's going on. Oops, I want green. This is equal to A plus 1 times B plus 1, and then minus a 2. Okay? And you can see why it works, because if I did a distributive property, you can distribute this way too. A plus 1 times B, and A plus 1 times 1. Got that. Okay. Well, in that case, why did I do this? I did this because it's actually easier. Because if I know that A ampersand 7 is 70, that's telling me that A plus 1 times 8 minus 2 is 70, right? So the first thing has already told me that if I took a plus 1 times 7 plus 1 and then minus 2, that's supposed to be 70. Why was this satisfying? I did that in my head earlier when I was deciding how to do this problem. Well, the reason it's satisfying is because, well, let's fix the minus 2 by adding 2. I got 72, and I see an 8. That's really satisfying, because I've 8 times something is 72. A plus 1 times 8, let's put these parentheses, is equal to 72. That tells me that a plus 1 is 9, because that's like how I divide out 8 from 72. So a is equal to 8. Okay, now let's just go and figure out the answer with the a ampersand 3. So I'll just do like this trick I've got. I will do again the a plus 1. Oh, look at that. I didn't even need, I feel very ashamed. I shouldn't have even done that. My style is always to do as little computation as possible. And I don't need this because I only need to know what is a plus 1 times 3 plus 1 minus 2. Okay? So to get the answer, I just need to know a plus 1 times 3 plus 1 and then minus 2. And I know what is a plus 1. A plus 1 was 9. So it's 9 times 4 minus 2. That's 36 minus 2. And that's equal to 34. So I think the answer is 34. Let's see. And a little bit of me is also checking, does it make sense? And it does make sense, because you see, what's going on with this ampersand thing is it's sort of like increase both numbers and multiply them. And it's close to that. Okay? But if you increase both numbers and multiply them, and you compare from doing it with a 7 to doing it with a 3, well, when you increase 7 by 1, it makes you 8. Increasing 3 by 1 makes you 4. And 4 is like half of 8. That's why the answer should be about half of the 70. This is just like how you would check. Okay, let's see. 34. Good. We still have some time. Question 17. Whew. Cody's alarm rings every 11 minutes, and his dad calls upstairs every 15 minutes to wake him up. Wow, this is a good sleeper we've got here. But Cody will only wake up if his alarm rings and his dad calls him at the same time. If his alarm first rings at 7 a.m. and his dad first calls him at 7:05 a.m., at what time will Cody wake up? Hopefully Cody's going to make it to school. Okay, all right. So now when I look at this, I'm like, okay, I need both to happen at the same time. All right. And I'm looking to see when we're going to have this pattern match. The good thing is that since 11 and 15, those are the two, let's not draw it that big. These are the two numbers. The two numbers are relatively prime. And furthermore, like, if I keep taking multiples of 15, they all have different remainders. When I divide by 11, after I've done it 11 times, I'll have hit every remainder. That's some number theory, actually. So I know I won't have to write like too many of these things before I go and find something that works. Because if I just go and like add, what's the better one? If I just keep adding one of these amounts, I'm only going to have to do it at most 11 or 15 times. It is easier for me to notice what it means for the dad to be calling upstairs, because the dad calls upstairs every 15 minutes. The first call was at 7:05, so I actually know the dad's calls. Here what I'm using is I'm using the fact that 15 minutes is a quarter of an hour, and it's very convenient. So I will say that dad, this is the very patient dad, very, very patient dad. Dad calls are at 05, 20, 35, and what's the next one? 50. Yes, those are when the dad calls. And now I just want to know, like, if I keep adding 11s, when is an 11 thing going to give me one of these remainders when I think of minutes? Already I'm seeing that Cody's going to get a lot of sleep here. So okay, Cody's alarm first rings at 7 a.m. And even in the first, like, 11, 22, 33, 44, 55, none of those were these, okay? So actually Cody's going to get like a lot of sleep here, all right? So Cody, he gets to sleep all the way through until like 7:55, no problem, because that's just double checking here, because that's the ending with a 5. I just want to make sure I don't have an arithmetic mistake. Dad first calls at 7:05, 7:05 to 7:55. That's like Yeah, that's still a lot of extra time, okay? That's sorry, not extra time, but I mean, that's 50 minutes. That's not a multiple of 15, okay? Now it rolls over. Now I have to be careful. If it's 7:55, the next one after 7:55 is obviously 7:66, right? Except that that's not legitimate. That's not a time. It's 8:06. All right, now I need to keep adding these things. 8:06. So after 8:06, what happens here is that I'll go to like 8, and here's how my scratch works. 17, 28, 4, no, not 40, 39. And if I could add properly, what happens here? 39, so not 40, 50. Ooh, it looks like we hit something. And so it looks like I've gotten like Cody's gotten lots and lots of sleep. And then somehow you go over here and it's like, oh, there we go, 50. So it looks like 8:50. So, wow, Cody, you got a lot of sleep. You started at 7 o'clock. And somehow Cody's alarm gets to ring a whole lot of times. All right. Now I want to show you an interesting pattern here. Okay. So this is what I did. I just like brute forced it all the way through. But there's something else that's going on. I want to show you what happens in terms of like what was the number of minutes since the last dad calling. Okay. So let's try this. So let's make a little chart, right? So so this is the alarm ring. Alarm ring. And then we'll also keep track of the number of minutes since last dad calling, okay? Make a big chart. This is number theory. So the alarm rings first at 7 o'clock. And the number of minutes since the last dad calling, I'm going to pretend that the dad actually called also at 6:50. And I'll say that that's 10 minutes since the dad called, even though the first time the dad calls is at 7:05. I'm just saying dad is like this automaton that just like calls every 15 minutes. Okay? The next alarm ring is 7:11. And the time since dad last called, dad called at 7:05, so that's a 6. Okay? The next one is 7:22. And the last time that dad called was at 7:20. Does that make sense? It's because dad's calling at 7:05 and then at 7:20. Notice any interesting pattern here? What is going on? 10:62. Oh, 10:62 is like -4, -4. Is there a reason why it should drop by 4? Of course there is, because what's going on is that the alarm ring is like every 11 minutes there's an alarm ring, and every 15 minutes there's a dad calling. How do you get 4 out of 11 and 15? It's the difference. It's the difference, right? So that's exactly where this is coming from. So you can see how the pattern works. I'm just showing you there's multiple ways to do this problem. 7:33 now. When was the last time the dad called? Well, the dad calls at the 05, at the 20, and at the 35. Oh, well, in that case, I mean, 20, that was 13 minutes ago. What happened to my -4? My -4 broke. I'm supposed to get -2 here, aren't I? Oh, yes, but it is -2. 13 is the same as -2 when I think about remainders when I divide by 15. And indeed it is -2, because in -2 minutes, dad's going to call at 7:35, right? So that is the same as -2. Effectively, I went to -2 and I wrapped around, because 0 is the same as 15. It's like a clock. Okay, so -2 down from this clock of 15 is going to take me to 13. Once you see that, you actually can go really fast. You can be like, okay, what is this supposed to be? Let's keep minusing 4. That's the pattern. 13 minus 4 is 9. 9 minus 4 is 5. 5 minus 4 is 1. 1 minus 4 is -3. Just kidding. You're not allowed to do that because 0 is the 15. So this is actually 15 minus 3, which is 12. Now you're already happy because you see if I'm going to subtract a few more, then I'm going to just get to 0. That's the entire point. That's when alarm and dad hit at the same time, right? So I want to get the 12 all the way down to 0. That happens at 8, 4, 0. Ding, ding, ding. This is when Cody wakes up. So now once I see that, here's another way to do the problem. How many of these jumps are there? Let's just count. 1 will take you to the 6. 2, 3, 4, 5, 6, 7, 8, 9, 10. So what I see here is that I'm going to make 10 forward motions. 10, like, forward motions means plus 11 minutes, right? So what I'm going to get here is if I go all the way down, I'm going to plus 10 times 11 minutes. All right, and if I'm going to do 10 times 11 minutes, then that's going to be 110 minutes. That's close to 120 minutes. That's what I'm going to call 2 hours minus 10 minutes. So that should mean that it should be like 9 o'clock, no, just kidding, minus 10 minutes. It should be 8:50. All right, let's go and check the answer. Let's see. It is 8:50. Okay. So we have just found out that if you try to have your dad be your alarm clock and have an alarm clock, this is highly inefficient. You might actually end up sleeping in for an extra 2 hours. Cody was probably late for school. Okay. Next question. It's 5:46. We still got some time. Question 18. The largest rectangular region shown is partitioned into 3 rectangular regions labeled A, B, and C. The lengths in inches of rectangles A, B, and C are n plus 3, n plus 5, and n minus 2, exactly, respectively. And all 3 rectangles have width n. I agree. If the area of rectangle B is 84 square inches, let's put an 84 here, 84 square inches, what is the perimeter of the largest rectangle shown? Okay. Now I'm having a bit of trouble. I'm reading this. I'm like, what do you mean largest rectangle shown? Do you mean the whole rectangle? I'm going to assume that's what that means, as opposed to this like being a rectangle, right? Because I'm just like, well, if the question was asking me for the perimeter of B, I don't really need to know anything else about A, B, and C. Okay, so I'm going to guess that the problem is saying I want the big perimeter. Now, what do I know? I know that n times n plus 5 is 84. Now, whenever I have something like this, if it's a chapter round or a chapter invitational round, and the question didn't say anything about simplest radical form, it means the numbers will probably be whole numbers. And if they're probably going to be whole numbers, then I say, can I factorize 84? 84 I've seen before. That's like 7 times 12. When I learned my times tables, I learned the times tables up to like 12 by stuff. Not because we were using base 12, but maybe because somehow it seemed reasonable to know the times table out to 12s. So I actually know that it's 7 times 12. Oh my gosh, look at that. That's perfect. Those are different by 5, right? Those are different by 5. And so they're different by 5. Oh, I see somebody. So 10 more. What do you mean 10 more? I'm not sure what you mean. It's 5 more, not 10 more. Maybe you're talking about something else. Anyway, so it's like 7 times 12. Okay, so if it's 7 and 12, and it's 7. Okay, let's see. What's the whole thing then? The whole thing here across the top, the way I'll add them is I actually won't first evaluate each of the pieces and add them. I like to collect n's and collect the other stuff because it's less mistakes will happen. So if I add the whole thing, I got 3 n's, okay? So the whole thing across the top is 3 n's. But then what else? Well, I also have a plus 3 with a minus 2. That makes only a plus 1. Plus a 5 is plus 6. Okay, 3n plus 6. Double checking, I could also do 3 plus 5 is 8, and then minus 2 is plus 6. Good. So I now know that my n is this 7, okay? This is my n. N is 7. So in that case, if I want to know the perimeter, let's still do the whole thing with n's first. I usually do length plus width, and then double it. So if I wanted to do double of length plus the width, that's going to be double of 4n plus 6. Notice I'm really saving until the last minute to go and slap the n in there. And so 4n plus 6 times 2, that's 8n plus 12. Now I finally go and put the n in. N is equal to 7. So 8 times 7 is 56 plus 12. And the answer to this is running into my head. That is equal to 68. Read the question again. Seems reasonable. This was a 7 by a 12. Okay, and we're good. If I actually wanted to check my answers, by the way, the easiest way to check your answer here would be to take the 7 times all of... Wait. Is that actually right? No, no, not times. Add. I have to add them. So I'd have to take a 7 plus... Okay, this is 10. Now I'm doing the opposite, right? I'm saying like that's 10 plus 12 plus 5. 10 plus 12 plus 5. That's like 22 plus 5. That's, if I could do math, 10 plus 12 plus 5. 27, maybe. So if I've got like 27 and another 7, that's going to be 34. Yeah, it's 68, 68, 68. Okay, so I just double checked. I think it's 68. Let's find out. Sometimes I'm wrong. Let's see. I'm sometimes wrong, but let's see what happens. It's okay. It's 68. All right. Next question. Ooh. What is the length of the longest diagonal of the rectangular prism shown, which has length 9 centimeters, width 8 centimeters, and height 12 centimeters? So whenever you see these kinds of things, it's actually like a double Pythagorean theorem. And I say that because I also see a 9 and a 12. I like the 9 and the 12. Because what I really want is I want this thing. That long diagonal. But to get that, I need to see a right triangle that gives you that. So I can actually make a right triangle by first doing this. What did I just do? That was supposed to be a straight line, but it wasn't straight enough. That's a little bit more like a straight line. So that's a right triangle, by the way. See that? That's a right angle. So it's like a 9, a 12, and a something. And I have another right triangle here. I want to have things look sort of parallel. Does this make sense? Like this is a slanted right triangle that's just kind of sitting over there. And so I just need to know this guy. But the reason I like it is because 9, 12, that's in a ratio of 3:4. We've seen that already today. If you have something, let's use green for this. If you have a 9 and then you have a 12, well, that's just equal to 3 times if I had a 3 and a 4. And we saw that already. That was a 3, 4, 5. So that means that this is 3 times 5 is 15. So now I suddenly know that that's 15. Hey, I have an 8 and a 15. How do I make a right triangle with that? You just use, well, how do I find the hypotenuse? You just use Pythagorean theorem. And this is a famous one. 8, 15. Well, what's the hypotenuse? The hypotenuse is the square root of 8 squared, which is 64, plus the 15 squared is actually 225. Okay. And that's actually nice. 225 plus 64. 5 and 4 is 9. 8, 289. It turns out that's actually 17 squared. This is one of the Pythagorean triples that I learned when I did math counts, because it came up so often. And if you haven't seen that before, that won't fit there. If you haven't seen that before, let's just do it up here. 17 times 17, that's like 49. 7 times 1 is 7, plus 4 is 11. Really? Okay. Yeah, okay, believe that. And then 7 and 1, good. 9, 8, and 2. Okay, so it's 17. So in that case, that means that the longest diagonal is 17 here. Let's see if this is right. And oh, by the way, if you didn't think about this, this is actually also quite standard. This is called the Pythagorean theorem in 3-dimensional space. Whenever I have points in 3-dimensional space, I can always do something like this, because every 2 different points in 3-dimensional space, you can always go and make one of these rectangular prisms. And then you can always go and take one of these face diagonals, that's what it's called, in order to help you with that other piece get the space diagonal. And actually, you know what? I should also say, there's a nice formula for that space diagonal. Because what was this 15? We did do something here with 3 times, right? But if you weren't that careful, and you just said, oh, you know what? Pythagorean theorem tells me this is just square root of 9 squared plus 12 squared, right? And then what would you do with that? Well, that's what goes here. So over here, if this thing here is the root of 9 squared plus 12 squared, that's going to go here. But if you're going to do Pythagorean theorem again, you're going to end up finding out that the question mark is equal to the square root of, well, there's an 8 squared, plus the other thing is the square root of 9 squared plus 12 squared squared. Hey, what just happened? How do you square a square root? You just get rid of the square root. So this is equal to square root of 8 squared plus 9 squared plus 12 squared. So this is sort of like the Pythagorean theorem, just with 3 things added together all squared. All right. So if you ever have like something where there are 2 points and they're like separated in 3-dimensional space, the distance between them is the square root of the sum of the squares of each of those gaps. Oh wow, this is cute. I'm seeing that my moderator crew, which also has a way to chat with me directly, Turtle Link has said there's a related puzzle: how to take a 1.5 meter flute through airport security if security won't take objects that are longer than 1 meter. That's pretty good. That's pretty good. I can also tell you there was some about story time, since that's what we just got to here. There was an airport I was once in where I just have to share this. There was an airport I was once in where like the chairs, where there was some lounge where you could, I guess, sit while you're waiting for your flight. But the chairs, if you looked from the top down view of the chairs, they looked like this. See, they were like this, but there were like some barriers. This thing was like it went up, you know, like a barrier. And this thing was also a barrier. Actually, they weren't barriers. They're called backrests, okay? I think usually people like them. So they're called backrests. So there were these 2 backrests that was supposed to say rest. So there was all of these things of like 2 backrests on a chair, okay? And there were all these chairs lying around. But unfortunately, if you tried to put 2 of them together like this, unfortunately, the airport had optimized it just right, so that if you tried to lie down like this is a really lousy stick figure, okay? But if you tried to lie down like this, it was like too cramped. It was just wrong. I don't want to say just right. I want to mean it was just wrong. It was designed so that there was no way, even for me, I'm not super tall, but it was like just so uncomfortable. I'm glad you like my art. The proportions are all wrong. This is like the longest neck ever. Anyway, but so we've got this, like it was not okay. And all through the airport, there were all these people who were trying to like move these things around, and you know, it wasn't comfortable because, you know, if you wanted to actually fit, the only thing you could do is to do this, which seems okay for the first 10 minutes. Oh yeah, I should have emphasized, what I do in airports is I try to sleep, and that's what everyone else was trying to do. This was like 5 a.m., okay? So if you have this, like, this is one way you could pull it off, because now you can have, like, you're okay. Except that if you sleep like this for 10 minutes, at some point it just starts to hurt, because it's like there's this gap in the way. This is just like not comfortable. You should never try doing this. And so everyone was like, oh man, this is lousy. You saw people curling up. It was just lousy. But I was very proud of myself. I came up with another way. Make them diagonal. Well, so unfortunately, if you try to make them diagonal, let's get rid of the guy. If you try to make them diagonal and you try to do this, oh no, that was my eraser. If you try to do this thing, it's like it still didn't quite work. This is still like too short. It was actually still too short. So that was not okay. So put your suitcase there. It was. I tried all kinds of different things. People were trying all kinds of different things. They didn't work that well, but this was still too short. Actually, since you guys are in middle school, you're probably okay. But I can tell you what I did. And it worked. It was awesome. I even took a picture and shared it on the internet. But like what I did is I did this. Take this guy, take this guy. Then you take this guy and this guy. And then you do this. It was perfect. So this thing here, oh, okay, not everyone here is in middle school. We got people here in college, which is awesome. But this was perfect because you see, you don't need this, right? Like, look, there's all this extra space here. Your back is not going to run into that. So you go and take this guy and shove it up all the way until it's like that's where your body goes. And bam, it was perfect. So, okay, anyway, I was very proud of myself. Let's go back and do math counts. But this is like Pythagorean theorem for you. Okay, what happened? What was the answer? Oh, the answer is 17. We're correct. All right. Well, actually, we have one more question. Let's do one more question. Let's do this one. We might go over time a little bit, but let's do this. Question, because I don't want to end on just the story. Let's do this problem. Question number 20. All right. Suppose there's an 80% chance of rain each day. On days that it rains, Kathy has a 45% chance of being late compared to a 30% chance when it does not rain. On a random day, what is the probability that Kathy will be late? Okay. So the way this thing works is we want to split it into like two possibilities. And so you got like either you have rain or no rain. Got these two possibilities. And going up each of them, like the chance of going into the rain is 80%. Wow, this is a really rainy place. 80% chance. I'm going to use decimals. Am I? Yeah, I guess I am. I'll use decimals, okay? So going up this way is 0.8. And no rain is 0.2. Reminds me of some places that I used to live. I used to live in places that rained a lot. I also used to live in places that didn't rain. This is like England. This is like Los Angeles. But let's keep going. So now the next thing is, if you have the rain, what's the chance that you're late? Oh, all I care about is late, okay? So the chance that I go on and I become late, now that's going to have a 45% chance of being late. Of course, there's another branch on this diagram I'm just not drawing because I don't care about not late outcomes. And then this guy, from no rain, it's 30% chance of not being late. Of being late. 30% chance of being late. Okay? And then what you do is you multiply. Because I've got 80% chance this way and then a 45% onward chance that it goes that way. And this is the probability conditioned on the previous outcome being that it rained. So I just have to add these together. I need to know what is 0.8 times 0.45 plus 0.2 times 0.3. 0.8 times 0.45, I don't like multiplying by 0.45, but I like multiplying by 0.9. So I'll divide the 0.8 by 2, and then I get to have a factor of 2 I get to throw into the 0.45 to make a 0.9. And the other one I already know what it is. It's 0.6. Okay? And that's because 2 times 3 was 6, and I have to move 2 decimal places because I've got 2 of them here. 4 and 9 is 36 plus 0.06. And as usual, we get an answer here, 0.42. We usually have an answer of 42% in, like, say, a math counts thing. 42 is this answer to everything. Maybe that's a good place to end. So I think the answer is 42%. The way I'll double check is I'll be like, well, it was somewhere between 45 and 30, right? Because those are the two possibilities. And somewhere between 45 and 30, actually that is like 42. Ooh, another cool thing. It's because it splits it 20 and 80. So actually 20 and 80 is a 1 to 5 ratio. This is a cool fact. This is it's a 1 to 4 ratio. It's a 1 to 4 ratio. So actually there's something else that just happened on the number line. If I took a number line, here's how I'm checking my answer. Over here is the 30% chance. Over here is the 45% chance. And what's the deal? The gap between these is exactly 15. And if I split the 15 in the 1 is to 4 ratio, which is exactly what you see with 80%. If you split it in a 1 is to 4 ratio, look at that. 1 is to 4 ratio gives you 3 and 12. And that is exactly where 42 is. We just double checked our answer. Okay, and it looks like people think 42 is the answer to the meaning of life. And it's also the answer to this question. With that, I'll say thanks to everyone for joining. We managed to get through question number 20, and we also managed to learn how to sleep in airports by moving chairs. We will continue tomorrow, exactly 24 hours after whatever it was that it started here in your time zone. For me, that's going to be 5 p.m. to 6 p.m. Eastern Time. Hopefully you guys had some fun. I definitely did. And I'll see you next time. Bye-bye.